I'm here with Dee Dee House, and as I was kind of thinking about all these LA fires, I thought it would be nice actually to have a dialogue with Dee Dee about this whole thing. She actually worked on this project called Rehydrating California. Um, so yeah, why don't you just introduce a little bit about your background, Dee Dee?
Sure. So I've been working on this topic of what we sometimes call the living climate or whole systems landscape function or the soil sponge uh, since about 2015. I started creating curriculum and a training manual called Understanding Soil Health and Watershed Function. And I've worked really closely with Peter Donovan of the Soil Carbon Coalition. I traveled with him a lot for a number of years, which is kind of gave me a lot of context for thinking about all of this. We were doing infiltration testing and bulk density testing and biodiversity observations and soil carbon testing, and then having really deep community conversations and conversations over dinner with the ranchers that we were staying with, who were all managing land holistically. And then also kind of simultaneously with that, working very deeply with Walter Jena from Australia, who's become quite a well-known name these days. Um, Walter and I met at a water conference, and he was talking about the soil sponge as foundational infrastructure to make the whole water cycle work, in terms of cooling the climate and everything else. And I was demonstrating with some students the concept of the soil sponge through this demonstration with bread as healthy soil and flour as unhealthy soil. But I didn't have that word, the soil sponge, to describe it. And I didn't have quite as much context as Walter provided. So we became friends, and actually he came up to Vermont for several days right after that. And then we started putting on a conference together every year until COVID hit. And in 2017, at our conference, we were talking about what to do next with the whole group, and people were putting all these sticky notes up on the wall of, we need to work on education or media or getting payments to farmers, etc. And then after that, he said, "Hey, there's one sticky note you missed down. It's down here, down under," because he's from Australia, and it was an audacious question around an audacious goal, is how he phrased it. Can we rehydrate California? And he said, we need to organize around this kind of question, not thinking about sort of like, what are the smaller things we do? And so I took it literally and said, okay, let's do a tour next year. So when he came back in 2018, we went off, and actually Peter Donovan traveled with us. So it was the three of us. And we went up through California, starting in Hollywood, ending up in Marin. So we didn't get through the whole state, but having these community conversations and also kind of educational talks about thinking about the whole water cycle and thinking primarily about the soil sponge as this foundation for everything else to work. So that, and yeah, since then I've done lots and lots of teaching and writing and curriculum development. Both.
Cool. Yeah, I
Yeah.
think your soil example with the flour and bread has kind of gone a bit viral, and yeah, and I've talked to a lot of people that have been really inspired by taking your soil and your workshops around this. And yeah, it's great that you've partnered with Walter, and yeah, cool that you did this whole tour around California talking about rehydration. And I don't know if it maybe it had some impact on me too, because early on with my Substack newsletter, I wrote something about rehydrating California to lessen the wildfires. And yeah, and maybe I'll share a little bit about myself too, because I think you're going to use it
That'd be great. Yeah.
for your podcast too. So I'm Alpha Low, and I went to grad school in physics, studying kind of condensed matter physics, and then I kind of got interested in permaculture and was in different land communities, and actually now I actually teach about water in permaculture design courses. And I was in a lot of the California wildfires and during the 2010s, and I was like, at one point, and then into the 2020s, and I was at one point, I was like, how come no one's looking at the water cycle, restoration of water to deal with wildfires? It's all about fuel reduction, meaning cutting down brush and trees to stop the wildfires, but no one's really looking at how we can rehydrate. And I think I saw something about Zach Weiss talking about how you can restore the small water cycle and also restore the land. And his advisor, I mean, his mentor, Sepp Holzer, was talking about if we drain the water from the land, then there's going to be more wildfires. And so here we are in California, and that's what Milan too. He was looking at restoring the rain in Spain and in the 90s, and because we're drying out Spain, and so that's why the rain was less. And he came to California, and someone said, "Hey, if your ideas are correct, California's going to have a lot of wildfires in 2010s." And lo and behold, it did. So, so I thought, and because this one hits a bit closer to home, this LA wildfire that just happened, and I think you also have a lot of your students that were in LA. So this one is a little bit more close to home. This one.
It is. It is. So a lot of talk on LinkedIn and on Substack seems to be the two places where this conversation's really taken off. And I think a lot of us who've been thinking about it for a long time are finding each other, which is really exciting, and finding kind of different strands and different strengths that we're bringing to it. And yeah, it's really exciting to have people like you in this with the physics background. And yeah, another person who hasn't really jumped in because I don't think he's so much on social media, but is John Norman from University of Wisconsin, who is the author of one of the foundational textbooks on environmental biophysics. And I've recorded one thing with him, but it wasn't quite, didn't quite follow. I think he had not gotten a lot of sleep the night before or something, so we're going to record again. But he's another great mind in all of this that I think when we can all get together, it'll be really interesting.
Okay, cool. Yeah, I think a lot of us who have been kind of plugging away at this water restoration thing noticed at the start of this year that, wow, there's suddenly a lot more interest in about, a lot more people starting to get to know about this. And so the word was getting out a bit. And then when the LA wildfires hit last week, it seems like there was a lot more talk than in the past about because there's wildfires hitting all around the world. But this time it seemed like there was actually a lot of people talking about we need to restore the water cycles and in LA and California. So, yeah. So maybe we could just kind of generally, like, do you want to just speak to the general idea of how hydration might help with wildfire mitigation?
Yeah, well, I think, I mean, one of the phrases that's been going around is that wet wood is a lot harder to burn. And so that there's that basic principle that when the vegetation is hydrated, when the trees and the grasses have enough water, that is one thing in terms of fire prevention, or even just when a lawn has more water in it, in the soil sponge, which is the pore space or void space in healthy soil, and the structural integrity that holds that together so that water can soak in and stay in this reservoir underground. Then in places like California, where there is a long, there's a rainy season if you're lucky, and then a long dry season, that the length of green is longer. So you can have a much longer green season when you have water at the root zone for plants. There's also an issue of plant health and particularly tree health, because trees are so long-lived, that a tree that is under drought stress is much more likely to be under stress from viruses, from fungal diseases, from chewing insects and all of that. So you're much more likely to have damaged trees that are dropping limbs, falling over, etc., in a landscape where there's not enough water being held in the land at the root zone for the trees. The third piece is not just that wet wood is harder to burn, but fuel on the ground doesn't break down. So limbs, leaves, etc., dry grasses that have been trampled down to the ground, for example, by foot traffic, Um, uh, in a dry landscape, those are just going to oxidize. So they're going to slowly dry out and lose their matter, their biomass into the air, but become very crispy and crumbly and fire prone. We see this like in the Southwest. You can see fence posts that were put up 100 years ago that are still standing. They haven't rotted off. And but in a wetter landscape, or in a landscape that is more biologically active, where you have more fungal activity of the saprophytic fungi that tend to biodegrade wood, then a fence post in the ground will rot off after 10 years, like here in Vermont, that you can't leave a fence post forever. Or a log on the ground is going to turn literally into beautiful soil in just a few years. So I can't leave firewood on the ground here if on my wood stove. It has to be up off of the ground because the fungal hyphae and fungal spores will just go right into that and turn it into soil. So that's really different in places that have seasonal rainfall and that have not found ways to preserve what used to be the water that was in the land. So in a more Mediterranean climate, you need the beavers, you need the wetlands, you need the soil sponge, you need a way of being in the land that is not disturbing its ability to hold water in the landscape. So that's sort of some of the foundational ideas. And there's a lot more. There's a lot about how does rain form that we could talk about that I know you're thinking a lot about right now and writing about. So the whole biotic pump and cloud formation, precipitation, nuclei, what happens with condensation and pulling in air. There's the whole issue of transpiration and latent heat flux. Anyway, we can get into all of that, but that's sort of the beginning of thinking about fire versus fungi, as Walter talks about.
Yeah. So as you're saying, like the water, if it's in the landscape, it affects the way the plants grow, and then when the thick way that breaks down. So if it's like brittle and lying around and flammable, or if it's actually degrading into nice soil. Yeah, there's some interesting ideas. I think NASA did a study, and some other people too, of like how soil moisture correlates with wildfires. So they looked at the places with more soil moisture, and they were a lot less vulnerable to wildfire risk. And Nick Steiner, who works with Zach Weiss in water stories and does a lot of water restoration work, he recently did this video where he shows a plant that he had that's had a lot of water, and then a plant of his that dried out, and then he just took a big, almost like a blowtorch, and like the one with dried out does kind of just burn, and the one with water, surprisingly, doesn't even burn at all. It doesn't even catch fire, even with this big fire that's breathing on it. So
yeah.
So it's key how we hydrate. And then the other factor that I've also been trying to raise awareness of is the groundwater levels, because in California we've drained a lot of the groundwater, so much so that in the Central Valley the ground is actually falling by a huge amount.
Yeah.
And because there's cavities in underground that then without the water they just crumble. So in LA it used to be called, there's a place called Artesia, and there's a freeway going through there called the Artesia Freeway. And Artesia well means that if you just do a pickaxe to the ground, water will spurt up like a spout. And so that's why LA used to be like that. The groundwater was all the way up. When the groundwater is all the way up, that means that that the plants are a lot more hydrated, because if they go beneath the roots, then you can't bring up that groundwater, and it's called hydraulic redistribution. And so the trees actually bring it up and then actually pass it around into the soil around it, and then also breathe it out so the air is more humid. And yeah, and LA used to be, people don't know this, they call it desert, but actually if you look at the old photos, in the 1800s, and like it's actually wetlands. Like there's wetlands all over LA, and Rodeo Drive is where the rivers met, and all of Beverly Hills is this wetlands. And um, yeah, it's just that we've kind of forgotten it because we paved over it. And then during the floods of the early 1900s, we channelized and concretized the LA River, so it's really ugly now. And And so that just funneled the water out of the landscape without having it infiltrate. And thankfully, we're starting to restore a little bit now, the LA River.
Yeah, yeah. And I guess that, all of the Central Valley used to be a lake, right?
Right, Tulare Lake, yeah.
Yeah, and then it became a very small lake, and now that's basically gone. Um, so yeah, there's a tremendous amount of water that has been drained off of the land, and also, as you're saying, like drained out of the groundwater, but also the aquifer below the groundwater. So we've pumped water out of both of those spaces. And the groundwater, I think of as being primarily a function of the soil sponge, and that the soil sponge can replenish that. And we've seen that in places where the groundwater levels will come back up again when people start managing the surface better, allowing
Mm,
cover crops, diverse vegetation, less or no tillage, not using nitrogen fertilizers, which break up those soil aggregates. They interfere with the microbial work that forms soil aggregates. So then you don't have that pore space in between all of the little mineral particles. So when we have, when we interfere with soil sponge formation, either we keep destroying it or we don't provide the conditions for it to reform, then groundwater is one reason groundwater goes down. But also, as we have less transpiration in the air, right? And warming from, from increased greenhouse gases and other things, then there's like the chance for water to evaporate more, right? The hot water can hold, hot air can hold more water.
mm,
So it's literally like sucking the water out of the ground then.
right. Yeah, I just want to throw some more soil moisture stuff too. Uh, there's a couple, there's a number of researchers studying the soil moisture, and I think Marissa Legg is one of them. And like they showed that in the Southwest United States, which includes California, that the soil moisture correlates to the soil moisture in the previous season and even 2 seasons ago, and also the heat. So you have more summer heat because your spring was less moisture and your winter was less moisture.
Mm.
And so that makes it really important that we actually infiltrating the water into the land. So LA actually had a big rains a year ago, but because it didn't stay in the landscape as much, it affects a year later when you have more wildfires. So it's really key. And Paul Dermeyer, he started this project called the Global Soil Wetness Project. So basically, mapping all the soil is a scientist who maps all the soil moisture all around the world with other scientists, and so they found that when they include the soil moisture in the weather climate models, that they can predict the weather a lot more. And so they study how the soil moisture actually sticks around, and so a lot longer than you might think, because it actually, some of it goes down to the groundwater and then comes back up. Some of it goes in the humidity, goes back down in the soil moisture. So even though your initial soil might stay there for like 2 months or 2 weeks after it evaporates, it actually still influences the landscape because there's a whole these other feedback processes that influence it.
So it's interesting that what you were saying, about we had all this rain, or not we, but LA had all this rain, right? Because
Yeah.
what I'm reading from some scientists is, that climate whiplash article that's been going around, that, oh, it's because we had all this rain, because the oceans are warming, which is true, that then there's more rain because there's more moisture in the air. So when it can come down, more comes down. But that then they're making this leap that then there was more vegetation, and therefore there's more fuel for fires when it gets dry. And I think there's an aspect of that that is true, but they're not factoring in that you could have tons of vegetation if you're managing the soil surface and the soil profile and how water's coming, when water does come, is it available later? Um, you know, Ali bin Shahid, who I talked to earlier today, was talking about this pump that he and someone else invented that senses, when things are low and brings the water up onto the landscape and lets it down up high so that it's filtering down. And of course, nature does a similar thing. So if we have things in place, for example, if the snowpack on the mountains is intact and we don't have pollutants landing on it and darkening it, and we are addressing some of the other factors of global warming, then that snowpack is going to gradually melt all summer long during what would be a dry season. And if we don't channelize that water, and we allow it to spread out on the landscape, and we have soils that can soak it up, or even pavement that can soak it up, and a place to store it, whether it's in the soil or whether it's in big holding tanks like it's a Tree People that's got this amazing thing on top of a hill in
Yeah.
LA. Yeah. Then we can use that water either through natural processes or human processes later in the season. So it's that things like melting snowpack that have been interfered with through, in one sense, through pollutants, right? That's one of the aspects. So,
Right. Oh,
and then the sequoias used to capture, and I guess some of them are still there, still doing that, but we had all these trees on the mountaintops that were harvesting fog. And when we were doing that Can We Rehydrate California tour, I remember we were visiting with a forester who said that there are places along the Pacific Highway where even in the worst part of the drought, there was always water running across the highway because there were fog harvesting trees up the hillside.
mm.
So if you
Yeah.
think about that as something that there's how much water is there in California? There's tons. It's the ocean. It's the whole length of the state, right?
Yeah.
You just need to know how to get it from the air and back into the ground.
Right. Yeah. The fog is a key component of California's water budget. So like it's kind of, you can imagine like your household has different water budgets. You're getting from the tap. Maybe you go into the store and getting water. But actually, there's this other neighbor that's kind of secretly coming and giving you water all the time, but you're not taking that into account. And most people forget about this fog because it's like that neighbor that's kind of coming over and giving you water. And Milan, the meteorologist who kind of helped discover how Spain was losing its rain because it was drying out. When he came to California, he was like, "Oh yeah, this is the Mediterranean climate here," and California these old cold ocean currents that the water evaporates in the summer and it brings us fog. And the redwood trees actually, I forget exactly, maybe a third of its water actually comes from the fog. Like they're drinking it out of the air. It's called foliar uptake. And so, but because it's a strange way of getting water, we kind of forget about it. But it's so key. And so what the problem as we've developed the land, like the coastal areas and all that, is that it heats up. So when the fog gets here, it actually evaporates and no longer is that fog. And so we've lost a lot of that fog. So that's why it's really important to rehydrate the coastal areas so that fog can come in further inland. And then, all the wildfires that we've had in a lot of the mountainous areas uh, probably would be less because they're actually getting some of that, either the fog or actually, second degree iterations of that fog that can happen in different ways because it helps the moisture, which then, because the soil moisture has this memory over seasons and 2 seasons, like it kind of propagates in. Like, like the soil moisture have this kind of traveling velocity that's a lot slower. The moisture hops. Yeah, and then
And
you brought.
it's not just the foliar uptake, but it's also like condensing. And it's like
Oh, right, yeah,
condensing isn't quite the right word because a lot of the fog is already in droplet form. But in any case, it captures it with all those feathery surfaces.
yeah,
Capture it, and that's where it starts dripping down, and it's dripping down to the roots. But if it's on a hillside or the top of a mountain, it's also dripping down to all the vegetation that doesn't have that ability, but that's lower down in the system. And then
right, yeah. So
there's
it's kind of
dew, and
condensing.
then we
Yeah,
have dew, that if you have a cool nighttime temperatures, because you allow the nighttime radiation window to open, so you don't have haze or pollutants, et cetera, in the air. You can see the stars at night. Then the heat that has collected during the day can be released. The surface is cool, and then water condenses on everything, right, on all the vegetation. So, but that only happens when you have a nice kind of moist thing going on, right? But like, you're right,
Right. Yeah.
the ocean is there all the time. It's that annoying neighbor that you say, oh, I don't need you, I don't need you. And then all of a sudden you're in trouble and you're like, where's that person who used to stop over all the time?
Right. Yeah. Yeah. I was on a place this past summer that where, yeah, where it was so amazing. Like where there were trees, you could actually get rain, and where there wasn't, there would be no rain. It was just because of this effect you were just talking about, where the trees actually they act like a nucleation device for the water vapor to become rain or to become liquid water.
Yeah, that's actually another one that's beyond what I was talking about, the just condensing it onto the surface, but now we're also talking about the releasing of all of the biogenic precipitation nuclei and cloud forming nuclei, which is a whole third
Yeah,
thing
there's a
or
whole
fourth
yeah, there's
thing,
a whole
whatever,
nother
right?
aspect.
Yeah.
Yeah. Yeah, these terpenes that if you look at some forests, like there's all this kind of mist and clouds that form just above the
Yeah.
forest, and it's like a lot below the bigger clouds. And you're like, well, how did that get there? And it's because these terpenes that the trees are releasing actually act as nuclei condensation that create these little fog machines.
Yeah. So there's so many ways that we can get water out of the air and back to the ground, and so
Right,
many different ways that we can actually hold it there high enough up on the landscape so it's slowly percolating down through. And we've interfered with almost all of those.
right. And that thing you brought up about climate whiplash, like, yeah, because now we're actually having bigger, when the rains come in the wet season, they're bigger. And then when they're in the, dry season, like the droughts are longer or less rain. And so that's kind of like oscillating forth. So that makes it all the more important that we actually, and we talked about this in our last podcast here, that like we need to slow the water down because if you don't, that water from the wet season will be all drained out of the landscape by the time of dry season. But if it's there still in the dry season, then all the extra plants you grow now can be hydrated. And so that's why it's so important to slow the water down. And so there's all these techniques, like if your soil is more organic, it can hold more water. If it moves through the groundwater, it takes 2 or 3 months to move through instead of a couple hours through on the surface of the water. So there's different ways to slow it, and there's permaculture earthworks techniques like swales and yeah. Last time we were discussing this analogy with the museum, that you can imagine people coming into a museum and then exiting, but if they don't stay very long, like 15 minutes, then you're not going to have that many people in the museum. But if they stay for 5 hours, then you always going to have a lot of people in the landscape. And so that situation where it stays there for 5 hours is like the slowing down of the water. So it's staying down there for the length of the season, and it's kind of going out slowly. But that doesn't mean that you've lost the water. There's still people exiting the museum. It's just now spread out, as opposed to you suddenly have a lot of people when there's a lot of like a big train comes in, or a lot of people in the museum, and all of a sudden no people in the museum, and all of a sudden people in the museum. This way you spread it out, so there's much more constant amount of people in the museum.
Yeah. Um,
Yeah,
and
so basically trying to get water. It's one of the central problems of hydrology for thousands of years, actually, is to get water from the wet season to the dry season.
yeah, yeah. And I think that, different places have figured out different ways of doing that, and people have figured out ways of doing that, and nature has figured out ways of doing that. We've killed off most of the beavers that used to be in California that were very good at doing that at elevation, right? And also down in the valleys. But I guess one other thing I would say about that is we have a tendency to think about building structures that are, and this is maybe what we got into last time, but building structures that will capture the water, a swale or something like that, or a pond. But the vegetation, when it's very diverse vegetation, is actually doing that, interrupting the flow of the water with every molecule that's flowing. Like every drop that's flowing becomes, spinning whenever it hits something. So we end up with turbulent flow, which disrupts the ability for the cohesion to create that powerful mass that's moving downhill and erodes soil and ultimately knocks over buildings. And so having that vegetation, having a very complex landscape as you're going down the hill, is part of what actually allows the water to flow, rather than just a big structure every 50 feet or whatever.
Mm. Zach Weiss of Water Stories, he works, he does land restoration work, and he was working in one of the areas in California, and it was on a reasonably steep slope, and so he built a kind of water, a pond to kind of capture some of the water, and so that's continually hydrating the vegetation. And so when the fires came, not this time, but like another time, all the neighbors got burnt and their land was not burnt because it was stayed hydrated. And so he talks, and then when the next year when there were big rains, like the kind of pond water structure that could actually captured some of the landslides, so then it didn't keep flowing
Mm,
and actually hit the house. Um, and so this is kind of, and this leads to this question of actually decentral. He talks about a lot about decentralizing our water. So it's important that we have these water bodies all around California, and Brock Dolman too. I think he had this whole group, which is kind of talking about the importance of decentralizing water, not just having them in these big central reservoirs, because
right.
you need the water on the land, in the groundwater, or on the ponds, or in the soil, because when there are wildfires, you need that water then. You can't funnel it. You can't right then try to
Yeah.
funnel all the water from the reservoirs to hydrate your land. It's too late. Um, and so, and then that's one of the problems with the centralized way of doing water, because California, I forget, it's a crazy amount of dams. It's 1,500 dams, or like
Mm.
really a massive amount of dams. And Zach also talks about how that's very energy intensive. Like California spends 20% of its energy budget of whole California on just moving and cleaning the water, which then means that that 20% of your energy is actually going to global warming. And so if we're doing this, in many places around the world, then just moving water around because of these big reservoirs and our aqueducts is causing the global warming, which then disrupts the water supply further. So it's not a tenable solution. And then it's also really disruptive ecological, processes, all the salmon swimming upstream. And they're actually a huge part, much more bigger part than most people realize, because the bears will eat the salmon, and then that poop of the bears will then go to build the forest. So a decent amount, I think, of the nitrogen content of forest actually comes from salmon swimming upstream. And so we need those forests to then evapotransport water to create a small water cycle and precipitation recycling. And so by disrupting this massive flow of salmon that used to come up all the streams in California and the Pacific Northwest, that come in and creating massive nutrient boost to all the forests there, that's all gone because we've blocked all these rivers. So I think this guy Cliff, I forget his last name, was talking to me. The analogy is to think of, we're blocking our arteries of our body, so then they're a lot less healthy. And so when we do take some toxin like carbon emissions or whatever, then our body can't deal with it because we've clogged our arteries. And so it's not just the carbon emissions important. I mean, you want to take less of the toxin in your mouth, but you also want to unclog your arteries. And so it's kind of important that we actually unblock a lot of the dams and allow the dams to actually overflow into the floodplains further down, because then they can actually overflow the banks, feed the high vegetation there, and then store up the groundwater. So then it's more decentralized all over, hydrating the environment regularly.
There's a beautiful book, a little book called Water: A Natural History by a woman named Alice Outwater, interestingly,
Mm,
uh, that that talks about the salmon, beavers, the bison, buffalo,
mm,
and I think one other species, but it's really, really interesting history that gets into a lot of what we're talking about today, about
mm,
how there were these larger processes that managed water. Like in the prairies, the buffaloes would roll in the ground and create all of these little buffalo wallows that were like little potholes that would collect the water. Oh, I think also the other one was maybe the um, like prairie dogs or gophers, you know,
mm,
the tunnels and channels under the ground, that with big rain can actually hold quite a lot of water and bring it down underground quickly. Um, and yeah, it really is like the anatomy of the landscape, and all of this workforce and those are the ones that are much more visible to us. those kinds of animals. But then there's, plant roots and fungi and all of the soil food web underground, et cetera, earthworms, things that are invisible to us that are doing a lot of that work below ground as well. That's just as important, if not more.
Yeah, all the beavers and all the soil and all the fungi and all the bacteria in the soil, like all these are so important. And yeah, beaver restoration actually is a big deal. Like I think it's like several billion. I forget. Oh, I forget the units exactly, but actually, the when there was like 100 million to 400 million beavers on in North America, and they actually created massive amounts of wetlands.
Yeah.
And the more I think about it, I think they actually brought some rain to America because they create all these wetlands that then can evapotranspire and add to the ocean moisture blowing in, and in through the small water precipitation or precipitation recycling create that rain. And that then leads to more forests growing. And those forests are then even better at transpiring during the right time to create the rains. And then, the beavers then have more trees to create more wetlands. And so it kind of this feedback loop. So then you have much more forests because you have more rain. And then the forests create even more rain. And so I think they actually overall had quite an impact on bringing the rain. And so, yeah, the key in actually rehydrating the landscape, and Brock Dolman and Occidental Arts and Ecology Center in California, they and others worked really hard to get beavers onto the governmental legislation. And now there's actually a beaver department in the California government.
Is there?
It's
Oh,
really
that's wonderful.
amazing. So
Yeah,
like
I have
some
another friend who's been working on that quite a lot. And yeah, there's several great books about beavers now. The one that I've read is Eager.
okay, yeah, that's
Really,
great. Yeah.
really good history that interviews Brock quite a bit. But one of the amazing things that the beautiful design elements of a beaver dam is that it's designed to fail. So
Mm,
eventually it will break down and fail. And then those places where there has been a dam, those wetlands become an incredibly rich soils
yeah,
that then can grow a very different kind of vegetation there. So it also creates that beautiful patchwork quilt of different, sort of smaller ecosystems within ecosystems. And that's that diversity that we know is part of what's needed for things
yeah,
to work well, including the rain cycle, in terms of having diverse forested landscapes that can put out different biogenic volatile compounds into the air to create,
right.
create clouds, create the rain, etc.
Yeah, the beavers are pretty amazing. I actually had Layla Phillips, who wrote Beaverland, on here on my podcast too. And yeah, and I think they're discovering like ranchers in Nevada and other places, Colorado, I forget where exactly, but they were pretty upset at first about the beavers. Then they actually found out, oh, they're actually replenishing our groundwater and actually helping our water supply. And so they actually changed their tone. And so there's a lot of ranchers in the southwest of the US now pro beavers, even though they weren't originally. And but in order to do this, I mean, we kind of have to work with the beavers because they do sometimes cause some issues, and so you have to work with that. And then you also have to set aside land so that the beavers have more of this land and rivers to restore. And so it's kind of like, but they are kind of performing this free work, like this huge amount of water engineering work that can redo our landscapes. And so it is a good larger strategy to use.
Yeah, yeah.
There's also another aspect that as this time as I started thinking about it, because I was thinking about Milan's insight when he was studying the Spain wildfires. He was looking at he could actually track which winds actually created the fires, and he also been tracking how much moisture had gone into those winds. And because there was less transpiration into those winds, they were drier, and so that's why Spain was having more wildfires. And so in this LA wildfire, because it was a little bit strange, like it actually came in winter when usually it comes in summer, and so I was talking to my friend in LA. He's over 6 foot tall, and he just got blown over by the winds. The winds were so big. It's this
Wow.
Santa Anas. They come from the Great Basin area in Nevada, and then blow across the desert, and then come up the mountains, and then come back down in these kind of Chinook winds. And they gain speed, and they get hotter and drier. And so when they get to LA area, they're like so fat. But this, like, they're way bigger now,
Yeah.
and so part of the reason, like, there's some scientists, Avasar and Dominguez and others, we study how like the winds, like the trees are important to slow the winds. And so if we kind of have less trees, it's going to have faster winds. And then the other thing is like the Great Basin area, they've taken out a lot of vegetation, they've depleted the groundwater. So that means there's a lot more drier air, right? So it's less humid. So
The
that's a
Great
problem.
Basin, the Great Basin is in Nevada.
Yeah, it's this huge area. I think it's several states.
Like Death Valley and all of that.
Um,
I know
yeah, not
I fly
exactly.
over it and I'm just like, wow.
Yeah,
Yeah.
it's hard for me to define exactly, but yeah, it's a large area, a very large area, and so it's creating these hot, dry winds. But that's in part because they have devegetated and degraded and lessened the groundwater. So we need to replenish it all there. So because that's impacting us, and then like if you're creating reservoirs too on the Owens side, valley side of the Sierra Nevadas, and capturing all that water in the reservoir so that it doesn't actually get to hydrate the whole landscape there, then that adds to the dryness and the heat of the winds. And so all along from the Great Basin all the way to LA, if we rehydrate that, that's kind of important. And I mean, and it's also tricky because if you are rehydrating, you are getting more vegetation for more wildfires. So that's why the worse it gets, the trickier it gets. But we really did this strategic plan quickly to figure out how to get the water. And so that's why, in some ways, it's more important to get the water in the landscape first, because then you're not going to have the wildfires. And so that's why all these permaculture ideas like terracing or swales to capture the rainwater or ponds, or replenishing groundwater is a key because then if you are growing vegetation, it's not going to catch on fire.
Yeah. Well, I think I mean, the other thing is using wise grazing techniques, so holistic management, as a way to manage the vegetation during, so that it's not tall and brown during wildfire season. Because my understanding is that a lot of these fires were starting up in the grasslands,
Mm-hmm.
coming down the hills, rather than in forests. That so managing vegetation through grazing rather than just cutting, because in grazing, of course, you're returning a lot of the nutrients to the land. So
Yeah, that's good. Yeah, because they're pooping into the land. So
right.
yeah, so it's kind of its managed thing. Because if you also don't want to do it in a way where they're eating the trees before they get a chance to grow.
Right.
So it's kind of like also kind of a bit of a strategic, nuanced approach with the grazing.
And that's so with holistic management, typically it's a decision-making process, not a method of grazing, but it's a decision-making process applied to grazing very frequently. And they're often using very small cells that they're moving the cattle through.
Mm.
So it involves a lot of fencing, but it's very temporary fencing. It's just a strand of electric wire. And so there's, you're getting a lot of animal impact in a small area. So a lot of trampling that vegetation down into the ground in a way that helps it to decompose, right? While also adding the urine and the poop, etc., from the cattle. Sometimes creating little pockets, for the rain that does fall to collect in the hoof prints, depending on what kind of place it is. But that's, we've seen like Joe Morris, who's up more further north, but he's got beautiful longer length of green and Morris grass-fed beef, and many other people. He's just one that I've visited a number of times, because it's creating a landscape that can hold water longer.
Right.
So then he has more food for longer also for the cows, but he's also a lot less fire prone.
Right. Yeah, animals are very key in this whole fire thing, and also in how we kind of manage our ecosystems. Yeah.
I do think that the loss of the trees is a really key thing, going back to the wind. And it's a very similar principle of creating more turbulence.
Mm.
When you have more trees, as what I was talking about with water moving down a hillside, that when you have more complex vegetation and stems and plant litter, etc., including beaver dams, etc., and that kind of messy landscape, that's how we slow the water down. And the same principle applies, that the more complex of a vegetation you have on a mountaintop or on a flat plain, the slower the wind is going to go.
Right. Yeah. So yeah, the vegetation and the trees are really important. There's a guy, Chad Hansen, and an ecologist, this Salala. They did a kind of a review of all of the forests in the west coast of the U.S. And so there's a a lot of them are managed because the U.S. Forest Service kind of logs them and get some of the timber. And then there's unmanaged forests where they don't do anything. And basically, the unmanaged forests had very little wildfire, or much less. And it was the forest that had been logged or kind of had more monoculture regrowth in it.
Right, like plantation.
That was, yeah. So those were the ones that actually had the wildfires. And so and the reason the unmanaged ones had less wildfires is because with all the brush that they didn't clear and all the dead logs actually absorb even more, like 20 times more moisture, I think, than the soil does. Like it's super humid, and so the forest has its own air conditioning and humidifying system that's circulating it. So
Mhm.
that cooling and humidifying makes it really hard for the wildfires to take root. And Anastasia Makariva talks about this too. She's from Russia. And she looked at the Russian forests, the boreal forests there, and the ones that were logged or stuff had happened to, there's now a wildfire problem in the Russian boreal forests. They're the ones that caught fire, whereas the ones that were unmanaged in the wilderness, they're not a problem with the wildfire.
And we don't hear about that, that I'm hearing that from you, and I've heard it before from one or two other people, but this idea that it's these plantation forests, which are monocultures or that are heavily managed so that they are essentially, maybe not mono, but bicultures or whatever, that those are the ones where the problems are starting. And I mean, think about it. We know that in any landscape, whether you're thinking agroecology or permaculture or regenerative ag or whatever you want to call it, that biodiversity is one of the key signs and necessities for a healthy system
Mm,
for all kinds of reasons. That's all different exudates that are going into the ground that are feeding different soil communities that are creating, you know, the ability for plants to take up different kinds of nutrients and have more water, et cetera. And then the intelligence of the above ground life from like, bees and pollinators and birds and bats, et cetera, to beavers. So creating that messy, edgy, edge meaning like different systems coming together in different unique ways. We know that's like, those are basically keys to healthy ecosystems. So is it any wonder that a monoculture forest is going to be more prone to certain diseases, to certain beetle infestations, to certain things that are coming through that then make the trees just more likely to be dead or dying or flammable, drying, not creating the sponge for the water below them, not having the mosses and all of the interesting stuff that could capture and hold the water even in a more rocky landscape. So
right.
yeah,
Yeah,
there's
yes, you're right. Yes, but biodiversity is so key. Like it's so much more important than monoculture. And yeah, and is it any wonder we have all these beta infestations, which is actually a huge problem in California forests right now. But if we actually restore the water cycle so that the forests were a lot more hydrated and kind of use more polyculture techniques, then these beetle infestation would probably be a lot less. It's kind of like the same with the body analogy. If you kind of clogged up the arteries, you've kind of you're only eating one food group and not
right,
eating other food groups.
right.
Like your body's going to not be able to adjust and deal with a problem when you're saying ingesting too much of this toxin. Um, and so yeah, so then you have all these like this infection or that infection in your body, and so yeah, so you're prone to more things like the beetle stuff. And yeah, and so also like they've done studies where biodiverse forests have much richer soil than monoculture, and so that means you can absorb more of the rain.
Yeah.
And yeah, and so there is a kind of current craze around tree planting to grow to help with the climate sequestration, carbon sequestration. And in general, it's good, but sometimes you're planting just monocultures, and that can be a problem. And you're planting non-native trees that actually suck up too much of the groundwater. So the key thing to realize, I came up with an equation that what's going down must be greater than or less than, equal to the amount going up. So so if you're drawing up more than you're putting down, then it's an issue. And so in Spain, they've actually, because in some ways actually Spain has gotten greener, but it's actually not necessarily good because they're planting these huge eucalyptus monocultures for the toilet paper industry,
Mm.
and so they're sucking up all the groundwater faster than it's getting replenished. Like because it's not necessarily bad to suck up ground because you actually want that to actually transpire to create rain. But if you're doing it at a rate faster than it's actually
Right.
replenishing, then it's a problem because 10 years down the line you have a problem. And
And a monoculture forest is, we don't really know this. I don't think it's been fully studied, but it seems that a monoculture is not going to create the kind of, uh, all of the terpenes and the pollens and the this and the fungal spores, et cetera, that will actually create a healthy rain cycle in
right.
terms of cloud and rain formation. So, yeah. Um,
Yeah, I think the way to think about forests is like kind of as an organ, and they actually need this diverse community to function properly as an organ. And if you're just trying to do it with monoculture, it's kind of like almost like yeah, it's kind of like putting in a pacemaker for your heart. It maybe does some functions, but it's maybe not so good for other functions.
so you mentioned eucalyptus trees, and one of the things I've heard Walter Jena talk about is that when they brought eucalyptus trees to California, they brought them as seeds, but they did not bring any soils along with it that would have the fungal communities that know how to decompose those very, very high, oily, flammable leaves and trunks and branches, et cetera, that are going to fall down from those trees. So that's one of the issues in California, is that you have this whole population of very flammable trees that grew up in a fire dominant landscape in Australia, that
Mm,
and nothing that knows how to degrade them.
right. Yeah. So yeah, it's interesting. Like you might not even think about that, right? And because the ecology is so complex, but that's why sometimes you really need these ecologists to kind of to enlighten us a little bit because there's key aspects. And so some non-native species are not that problematical, but some are. And so like yeah, and as we kind of do this strategic plan to regenerate or rehydrate California, like we need the ecologists' help in kind of figuring out what to grow where. Um, yeah. I also want to kind of bring up some shifts in the LA water department, their perspective. So many years ago, they're much more this drainage paradigm of water management. But the tree people you mentioned earlier, Anthony Lipkas, he was really pushing. He formed this other group called ALA to look at kind of climate resilience for LA, and so they were really pushing this rain infiltration or hydration of LA. And so he then got 6 other agencies in LA to kind of look at this. And so they all kind of liked this idea. So then they actually then got in contact with the LA water department. And so over a couple of years, the people who run it now said they have a paradigm shift. They now realize the importance of rain infiltration. And so between the streets and in the freeways, they've started putting in rain gardens. And so
Mm.
there has been a shift to so some of the groundwork, if we're going to do this paradigm shift for LA and California, has started to happen. But of course, like LA is still so concretized and so little ability to rain infiltrate. But at least like in the LA Water Department, they're at least recognizing that this is actually
That's
where they want to go.
Yeah.
And the Chinese Sponge City initiative, where the Sponge City is, like 300 projects in a city to kind of infiltrate rain better and to slow the
Yeah.
water. Like that took off in China. And now other countries around the world are copying this Sponge City. And so there is a kind of template that LA and other cities, in Fresno, Bakersfield, in California could use to try and it'd be tricky because it means kind of undeveloping. In Chinese governments, they talk about negative planning, which
Mm.
is kind of surprising because I've been kind of trying to promote this idea of undevelopment, but they're actually doing it now. They actually know that you actually have to depave and
Yeah.
undevelop things because otherwise you don't have enough nature to infiltrate the rain. And so at some point we're going to get enough of a cultural momentum in the US to actually be able to actually realize we actually need to restore the floodplains, which might mean undeveloping, certain concrete areas and stuff like that.
Well, and I mean, that's one of the things I was talking 2 nights ago with like I said, the group, I have a group that meets weekly, the Land and Leadership Development Community, and several people are from LA, and Linda Gibbs and Lily Foster and Angela Geige and some others have a group called the Soil Sponge Collective, I think that they call themselves, in LA. And they were talking about there is an opportunity here in some of these neighborhoods, particularly that I mean, the neighborhoods are basically gone, so they are going to have to start fresh. And as people rebuild, it is an opportunity to rebuild, not just with houses that are hardened against fire, which is one thing, and I think that is important, obviously, but with landscapes that are sort of softened against fire.
Mm.
That we don't have all of the pavement we have, or that the pavement that's there is more permeable, that we have, we don't have just rock gardens outside, or roofs that have nothing on them. LA, that has tremendous potential to be more of a sponge city, maybe not full on, but including the LA River, right? I mean, when you look at those sponge cities in China, they have these marvelous parks all along the river that are really designed to infiltrate water as it falls, but also as it flows through.
Yeah, it'd be nice to see the LA River. Yeah, they started actually regreening, which is nice, but there's still a long way to go. And there are lots of issues too, because it's been so narrow that as you kind of regreen, it will actually change the water flow and it would overflow the neighborhood. So there kind of has to be some decision debate about how exactly you can do this. But yeah, it'd be really cool to see the sponge city kind of coming into being more. And there were kind of some proposed projects too, like I think hundreds of millions of dollars to kind of create more aquifer refilling too in LA, like Burbank, to have this kind of wetlands park that infiltrated the rain. I don't know if it's how far it's progressed. It was like, a decade-long process, but there's like 9 different wetland parks, I think, proposed for LA County area. But it's almost like you need this momentum, this cultural momentum to realize it. And this year, at the beginning of the year, there was beginning to be this cultural momentum. It seems like a lot more people are becoming aware of how important of restoring the water cycle is in general for our climate. And for this LA wildfires, a lot more people have been speaking about restoring the water cycle. So if we keep spreading the word, then it actually makes it easier as a kind of cultural entity to kind of do this work. That maybe people will have to make sacrifices because there's some things that have to give in order to undevelop enough of LA to have it infiltrate more rain.
Well, one of the things that I saw, when we went through with our speaking tour in 2018, the Can We Rehydrate California speaking tour, was speaking and listening, I should say, because we had long listening sessions as well with the people who came. The people who came were very interested, but the California culture right then had just caught on to soil carbon as a concept, as a drawdown. And there was so much excitement about soil carbon as drawdown, which is what brought me into this work as well. Like I was excited by that initially too, that everything was already pointing in that direction. And people did that thing where they hear what you're saying and they'd be like, so we should have more soil carbon, we should use more biochar, we should do this with, so, and they already were doing like soil carbon planning, and they had everything sort of set up for that to take off. And so it was like, no, don't talk to me about what's actually going to help, because we already have we already have our plan in mind. And they were real champions for soil carbon, getting it on the map, which, I mean, nothing wrong with that. It's just like, we were, 7 years too early for people to really hear the water message. And Mikhail Kravchuk had the same experience right around the same time. He went through and did all of these talks, and it was like people couldn't really hear the water message because they were already on that soil carbon track.
Mm.
And what we're now realizing is, yes, the carbon cycle is super important, and it certainly has a lot to do with what's going on with the climate, but it's only part of the picture. It's not and we can't just address climate through the carbon cycle. We have to look at water and biodiversity and all of these other processes as well.
So it is really important for the carbon cycle, and that's really key because we need to draw down more of it. And I think we're at the same stage as the restorative soil movement was 10 years ago with the regenerative water movement or the water cycle restoration movement. And because things are quick enough, like I think our movement can take off quicker. And so yeah, because like even on the national debate stage for the elections, like soil was brought up, like, and I was kind of
Right.
surprised that
Yeah.
it reached that far. But yeah, that's the soil carbon aspect. But the fact that the soil is important for the water aspect is not so known. But it's now, it just seems this year it's starting to get out. And yeah, and thank you to people like Walter Yen, who's really been plugging away at it for many years, and Mikhail Kravich has really been a strong voice, and actually not just speaking about it, actually doing on the ground
Yes.
projects in Slovakia and elsewhere. And he actually came to LA or outside LA in Ventura area, and he did calculations about how much you need to infiltrate, and like he could say that this much infiltration would actually lead to an increase in rain in the Ventura area. And I think
Yeah.
recently he kind of looked at LA a bit too. And so, yeah, so because California, and I think LA has lost like 30% of its rainfall over the last few decades. But some of that's due to climate change because of the ocean warming. I mean, anyway, various factors in global warming that reduce the rain. But that's only part of the cause of the loss of 30%. There's actually a decent, maybe half of that is actually due to the land degradation part. And so, um, yeah, we need to kind of push that message that you can restore the rain. And Michael Kravich is one of the few people really pushing it hard for many years. And thankfully now we have more people willing to push the message.
Yes, and let's not forget, as you mentioned earlier, Anastasia Makareyeva, who's
Yeah.
really, I'm so excited that her voice is finally getting front and center stage.
Well, she
So,
started a Substack too now.
yes, I know, I saw that. Very exciting. Yeah,
It's the place to be these days.
it
There's
is.
actually a movement of like many Substack. Like I'm surprised at how many, like 8 of them are talking about the small water cycle now. So
Yeah,
it's kind of gone viral.
yeah. And Rob Lewis is such a marvelous writer on all of this too. His
Yeah.
pieces that he did on Milan, as you've also done some wonderful ones. Not forget him because he's a very dear soul and a wonderful writer. So
Yeah. And then Judah Schwartz wrote one of the first books. Well, that I
she's
know.
the one who
There's
got
probably
me
other people
into
writing
this.
books, but yeah, Water
Yeah,
in Plain Sight and the Reindeer Chronicles. And then recently, Erica Gies wrote Water Always Wins,
yeah,
and Ananda Fitzsimmons wrote Hydrate the Earth, yeah, or Rehydrate the Earth, yeah,
yeah.
yeah. So it's good to get these books, and then I think there's a couple of films out there. I forget the names, but there's some documentaries about water out there too.
So Regenerating Life by John Feldman.
Ah, yes, that's right. Yeah,
So that actually got started at our Soil Sponge Conference and the Biodiversity for Livable Climate conferences.
right.
Um, um, and Walter Yena is a major part in there, but it was all filmed here in Vermont at my friend's house. And he
Okay.
gets into the work that we're involved with in Andhra Pradesh, India, where they're really doing an incredible amount of work. And they have 1 million farmers who are doing biodiverse 365-day green cover that's staying green even during the brown season. So showing that you can do this even in the midst of places where other people's land has already gone dry. They may have a hectare, so that's green and lush and just amazing drone footage. If I always think if you're a bird or an insect flying over, where would you land? Like clearly on one of these farms.
Mm,
So they're showing that it can be done, and they're showing that there's water available even without adding water, through irrigation. And
right.
one of the things that Walter figured out or brought up while we were trying to figure out why their experiments in 365-day green cover and planting before the monsoonal rains, why they were working, is that when you get soil biology active and the soil food web everything starts eating each other. Of course, all of those, even single cell organisms that are eating, one another are releasing water. Just like if I eat a watermelon or, a chicken or something, I'm releasing the water that was in the cells of that food. So that's
Mm.
going on underground. And that metabolic water or biological water uh, can be enough to help sprout the plants and kind of keep things slightly moist. It's not really enough to fully grow the crop, obviously. But then also when you have a much more mycorrhizal soil, the mycorrhizae can get water films that are not available to plant roots off of
Mm.
the inside of those soil pores in the soil sponge. So that's two sources of water that are now available. And then if you add in dew as a third one, so even without any rain, those are three ways that we can actually allow more water to be there for the plant.
Right.
And then, of course, when you have a diverse plant cover, you're not evaporating as much water. You're keeping the surface much cooler. So there's a lot less evaporation from the surface there. And it can also capture the dew, et cetera. So what my house plants are a great example of it. I mean, I do not water them very frequently and they managed, they may not be the most beautiful, healthy plants, but it's amazing how long a plant can go without water. And in circumstances where they have all these other things going for them. So they have a diverse soil food web that's eating and activated and et cetera, releasing water, fungal hyphae that can access hidden water, a deep soil sponge with a reservoir of water that's building up over time, that groundwater you were talking about, and cooler surface, so less evaporation, and then more ability to capture dew. That's a lot. That's a lot of
Yeah.
water. That's a lot of sources. And then we bring in California, we've got fog, right?
Right. Yeah. So when we're calculating our water budget, we have to include these things that we forget about that actually are really key. So all these organisms breaking down to get the hydration and the fog. Yeah. Um, yeah. I want to add a slightly different topic that what's happening in California is also important for the rest of the US
Yeah.
because like Francina Dominguez and others, they showed, and I think Rong Fu, who's an atmospheric scientist at UCLA, they found that the droughts in the Midwest, like in 2012, there was huge droughts. The cattle were dying, the farms were going under. Those droughts were in part caused by California, or like because the moisture hops from the
Right.
west coast of the U.S. into the Midwest. So
Yeah.
there was a decent amount of that, but that also means the droughts hop inward, and so it takes about 3 months to get there. But so the droughts in the Midwest in the 2012 were due to the droughts in California 3 months earlier. But if they had actually absorbed a lot more of the rain from either the previous seasons, then they would be able to moisture cycle a moisture hop more rain into the Midwest. And so what we're doing here is of importance to them, and it's also of importance to the Colorado River, which supports 7 different states with its water, because there's a lot of moisture hopping inwards, and so we kind of have to look at this kind of holistically, because in order to get that rain to replenish the water supply in the Colorado River, we need to actually do restoration work on the land all over in the neighboring states. And if you do withdraw all the water and put it into reservoirs like we're doing right now in Lake Powell and other areas, it's a huge problem, because that means that water then can't go towards Mexico and the Gulf down there. And so that means the river there that was huge, I don't know if it was 10 kilometers wide or something, or really big, is now just, a remnant of its former self. But that means all that landscape that was hydrated down there and that was growing and that could be transpiring water to create a small water cycle to create more rain in the Colorado River, it's not happening. Instead, it's being drained
So
to the
when
city.
go ahead. Yeah.
So a lot of that's being drained to the cities, and some of that then goes out to the ocean. And so and some of it will actually go up from the farms to then infiltrate to hydrate and create more small water cycles. But there is this net loss that I think, I mean, hasn't been looked at by the research scientists, but to me, there's this big loss because you've degraded all this land at the end of the Colorado River that could be a big part of this precipitation recycling.
So that makes me wonder, when we think about it on that scale, right, and how that dehydrates what's downstream that should have been downstream.
Mm-hmm.
How does that compare with like creating ponds high up on the landscape versus a soil sponge, or versus letting the stream continue?
Yeah, so it's the whole slow water thing, and so yeah, it's a difference between small dams and big dams. There's multiple differences. One is the sediment thing. Is the sediment can flow out of the ponds and actually still be part of the landscape, and some of that can flow all the way downstream and then during the big rains overflow into the, and so that sediment. The problem with the big dams is that sediment gets trapped, and so it's not like soil is a big component of how we build our landscape, and so that is taken out of the fact. And then
and it's cost billions of dollars to dredge those dams also.
Yeah, and it's a huge problem. And so that, all that soil or sediment that could become soil is like wasted. And also these smaller ponds, they can overflow themselves and actually hydrate all the environment and all the groundwater, and that groundwater can keep seeping and move further down. Um, and it's not like trapped, and those ponds are not, they're not usually going to cities that then funnel it out into the sewage, and they're actually usually used by the native vegetation and the native animals, and so it's kind of different. And yeah, it's really important that we decentralize our dams into small dams because you want water available everywhere. It's kind of like if you had a society, all the money was in some big bank, and then every time anyone needed money, you just get it from the big bank. But it's
That
actually
is
much
what
more.
society's like.
You actually want more important that
very-
have everyone have their own bank account with some money in it, right? And so you have some freedom, individual freedom of what to do, and that you each person in each organization creates their own ecosystem of money cycling.
Yeah.
So it's
So,
circular
and actually,
economy.
so it's interesting you bring that up because one of the things that we're looking at in our local conservation district, where I'm one of the supervisors, is looking at state banks as a way to recycle the money in order to rehydrate and regenerate the landscape. Because it's a very, and this is in my new training manual that for the UNFAO, that we look at these cycles. So there's the water cycle, there's the carbon cycle, but there's also the economic cycle. And if you are always either accumulating all of the money in this one place that then people have to go to and ask for, and somebody else is in charge of what you use it for, versus decentralizing it, that's a problem. And also if every time that like it rains money, right? If that, so everybody gets paid on Friday, right? And if everybody goes and spends that at Walmart, none of that money is really staying in the community other than for those employees get paid that day. It's all going back to some other place. Likewise, if everybody deposits their money into a city bank or something that is like a corporation out there that isn't providing it back into the local economy and ecosystem and farming community, etc. You don't regenerate that money. Whereas if I bring it to the state bank, which North Dakota has, it's the only state I think that has an active one. Very, very interesting article I just restacked about state banks. So
all credit unions too, yeah.
Credit unions also. So in North Dakota, when they collect taxes or, parking ticket fees or whatever, that money doesn't go off to some other investment fund. It stays in the state bank. And then the state bank can provide very low interest loans with that money to the local businesses. So they have a very vibrant financial ecosystem.
Right.
Likewise, if I shop locally, so if I get paid and I go to you and I buy some pumpkins, and then you go and you buy some milk, and then and we keep shopping locally, every time that money passes hands, like that same dollar, now next week it's $2, and next week it's $3, next week it's $4, it's all stayed here. So literally that $1 accumulates and we're all richer.
Right.
So it's, yeah, it's this very similar to the water cycle.
Yeah. Well, last time we talked about museums and flour and bread as metaphors, but I think this time we also have the banks we can throw in there, banks and
Right.
museums and flour. And to extend the bank metaphor a bit, like it's a common analogy in the hydro world to talk about groundwater as a bank. So you're banking your water. And it's really important because, and the trees will actually push it down during the wet season to increase that bank supply and then bring it up during the dry season. So then they actually can create rain during the dry season through transpiration and hydrate the soil. And so yeah, if you take away all the money in your local banks, then you can't actually give money to the local community to do all these things. And so that's like taking all the money out of groundwater. And so we don't quite understand. People don't recognize how terrible it is that we've been draining all our groundwater around the world, and what a big role it's played in wildfires because you don't have that bank, or in this case, it's like a bank of water, like to actually put out the fires or lessen the wildfires because it's disappeared. And it's just stored in these big reservoirs, which you don't have time to get to. And then from a complexity science viewpoint, for those of you guys who are listening who say complexity science, it's kind of like when you decentralize it, there's a lot more different actors that are working all their own relationships to each other that kind of create this emergent behavior that's kind of self-organizing the whole system. But if you only have this one or two big actors that are holding all the water, then to have them make all the decisions of where the water should go at what time, and if there's a big storm coming, how much we put up the dam walls or how much we release into the rivers, like these big decisions by central actors, it can't deal with the huge complexities of nature that if you decentralize the water, all the local animals and the soil and bacteria are actually making all those decisions of how that water goes.
Yeah, yeah, absolutely.
So should we do maybe we've been talking for a while now, maybe do a little bit of wrap up of
Yeah, let's do that.
of the different things we want to do to rehydrate California and LA to lessen wildfires. Like what's the larger strategic plan?
So yeah, there's a larger strategic plan, and there's also like what can people do locally?
Right.
Maybe starting with that, thinking about um, that as people rebuild, or as they're building new, or as they're doing maybe planning commissions for their neighborhood, etc. Um, thinking about softening the landscape while hardening the houses.
Mm,
So hardening the structures so that they're less flammable, but also depaving, uh, creating rain gardens, creating like Miyawaki mini forests, and a lot of diverse vegetation close together, um, and finding ways to put gray water, or leftover water back into the land,
mm,
finding ways to capture the water as it comes through the landscape. Um,
right.
so those are a few things, including, and depending on what level you're at, it can include green rooftops. It can include, like we said, rain gardens. It can also include permeable pavement and driveways, anything that allows that water to soak in. And then on a larger scale, that's like, yeah, turning the LA River into a whole sponge city park.
Right.
Uh, um, okay, those are a few that are on top of my head. How about you?
Okay, yeah, that's a good start for the local things. Like, yeah, there's a lot of things as a people we can kind of do on our own, like the things you were suggesting, and then also, like rebuilding your soil and maybe putting culture where you're using logs to absorb it. Maybe not letting your lawn, if it's allowed in your homeowner association, to let your lawn grow and have more of a polyculture in your lawn as opposed to all this grass. And that infiltrates the rain more. And then yeah, maybe at the slightly larger level, municipal area, like maybe you could create the watershed councils, which are looking at to restoring your creeks, to kind of getting more permeable pavement, how you replenish your groundwater. Because if you can get, like in Grass Valley in California, like it's just at that level where the tree roots cannot reach or can reach. So if you actually did a lot of work with swales or other ways or ponds to increase the water, the groundwater, it actually would hydrate Grass Valley and make it a lot less likely to get wildfires. And then, yeah, and kind of doing these decentralized things. But that also requires some work at the state level, I think, to get the legislation. And there's lawyers who are interested in this. So I think the water management people, the land people working on the land, like work with the state legislators to kind of get these laws that allow more decentralized water bodies, and various things, and more beaver stuff. And like that kind of has to work. And then, um, and yeah, because the LA Water Department is more open to this rain infiltration, kind of come in with various, like these sponge cities have like 300 projects, kind of go to them or work with them somehow, the different various organizations in LA, kind of, hey, this is how, I think, there's probably like 50 organizations in LA interested in this, like try to come up with this sponge city plan together. Like these are all the projects we can do. And then also all along the way to San Bernardino into the Great Basin, like all that area needs to be rehydrated. And then while we're at all the Central Valley and that area too, Fresno, Baker City, like there's all like because that moisture gets recycled. All these areas, the more they reach, that also increases the rain in the Colorado River and into the Midwest. So it's really important, on the larger scale. Yeah, and I think like like Andy Lipka's got 6 agencies, and then those 6 agencies then had enough clout to get it to the LA department. And so the more different organizations in LA that you get to know, or in California, then at some point it gets a tipping point at the state level that then it becomes this general plan to rehydrate California. And so, it's like you got to come at it from multi-sectoral. And so every one of us is usually standing in 2 sectors. So maybe we can bridge that water knowledge into that other sector. And at some point the momentum is rising now. It's like a lot of us can feel it, like it's awakening. And so it's a good time now to push all this knowledge in all the different departments and sectors in LA and California that kind of can awaken to this water paradigm.
Yeah. So then I have 3 other things that I think, 3 other areas that I think we can talk about. So we talked about kind of homeowner level and neighborhood level, and then city and state level, but also thinking about 3 different land management types. So in forestry, we talk about shifting away from the monoculture kind of plantation thing, and also from the managing just by cutting, and shifting toward understanding how do we increase water supplies within the forest through like allowing more beaver activity, through also using fungal biostimulants to help degrade the wood that is there, maybe bringing in some of what's needed for those eucalyptus family trees to degrade those, so that we have more humus forming and less just fuel lying on the ground. And having healthier forests through having more diversity and recognizing that. Creating, kind of noticing what's happening with those winds coming in and seeing what can we do to create more windbreaks along the way. But then also in terms of grazing, rather than having places that either just cut or let the grasslands grow, or leave just like a few animals kind of wandering around very randomly eating the things they like, and leaving the woody, more flammable shrubs, which typically animals will do when they're not well managed, to shifting to a holistic management approach to making decisions about grazing, and moving animals in en masse with fencing, using goats. Some people are doing kind of amazingly, going in and helping to herding the goats through, again, moving, in a community where they really kind of have to eat all of the stuff, and they're very good often at getting rid of some of the things that are more flammable. And then lastly, in the more fruit and vegetable farming, again, shifting away from monocultures toward much more polyculture, bringing in, having cover crops and using the animals to graze down those cover crops so that there's less tillage, because tillage is one of the big things that breaks up that soil sponge, makes it harder for the rain that falls to be absorbed, makes it harder for that deep reservoir for groundwater to form across the landscape. So yeah, a lot more emphasis on diverse cover crops. Christine Jones and others have found that when you have 4 plant families and 16 different species, that something called quorum sensing starts to happen, and the soil food web just explodes with activity, which will, as we were saying, provide more water underground as there's more organisms eating each other, and just more life underground in general is going to make it more watery underground. So
Yeah. So you're saying,
shifting away from monoculture, both in forestry and also in terms of crop farming and tree farming.
cool. Yeah. So you're saying beavers, soil, cover crops, polycultures. Yeah. So those are really good things. And I want to add, like on the larger level, once we get enough momentum, I think it's also key to look at this whole dam paradigm that's kind of clogging the veins of the earth. And we've recently, actually, through the Klamath River, has been undammed, so it's actually
Yeah, very
starting.
exciting.
And they
Yeah.
actually work with the indigenous people. Yeah, and so we've got to get the policymakers, the sustainable people, the indigenous groups, kind of working to undam the rivers. And it's still like there's not enough hydrologists working. They usually study how the dams work, but actually we need them to study how the dams don't work, because they're actually degrading all the land downstream. And they need to work with the climate scientists, because they study the precipitation recycling, how that lessens rain. And so that whole area has got to be studied more. And but like we then, because they're only looking at one picture, so it seems like if we just study the irrigation and the dams, oh, it's actually good for our society. But actually, if you put together the whole holistic thing, then maybe this hydrologists and climate scientists and ecologists, and well, the ecologists are already starting to recognize, they just see more the ecology part, how it's bad for the fish, which is true, but not how it's affecting the whole water cycle, and the hydrogeologists. We've got to put that all of those groups together to work to show actually why the dams are a huge problem. So that's kind of a larger goal. It's going to take a little longer, but we already started with the Klamath, so maybe these 1,500 dams in California can start getting unclogged. And I think once we start doing that, we'll see, much more huge ripple effects of rehydration. So anyway, we're going to build to that kind of level of being able to do that.
And if that water were available, I think the ability of the green vegetation to stay green into the dry season would really change, which
Right.
reduces the flammability, increases the amount of time that those plants are putting out root exudates and feeding the soil food web, and creating that sponge structure. So it all builds on each other. And I mean, the hopeful thing is that now that we're starting to see how it all works together,
Yeah.
we don't have to say, oh, here's a problem and here's a solution, or it's like, it's actually, we can start to find these nodal intervention points that,
Right.
hey, if we do this, there's like 25 other things that are going to change in ways that we can't even imagine yet, like how fast
Right.
it can happen.
Yeah. Yeah. Like you're saying, like when the dam, like it will allow that water decentralized, so it can be continually hydrating the environment. So those plants will all get hydrated, so they have less wildfires. Yeah. So.
No. And then the last thing, and of course here, the air temperatures are part of the issue, but keeping that snowpack for longer.
Oh yeah.
And that part of that is about not burning, so if I don't know if California does crop burning, but the way that one of the things that happens with the snowpack is that in the Central Valley, with all of the plowing and tillage, and the destructuring of the soil that's happened, that it's turned into flour instead of bread. When the wind comes through the Central Valley, that soil is in the air, right?
Mm.
And so some of that is landing on snowpack areas, and you can't even see the mountains a lot of the time in Central Valley during that season when they're doing that tillage, or even just when it's a windy season.
Mm.
And so if there's cover there, and if those soil aggregates are strong and the soil sponge structure is there like the bread, then the wind can come through and nothing's going to move.
Mm.
That's going to keep the snowpack for longer.
Okay, cool. Yeah, so there's connection to the snow quality, soil quality, and the snow. And the
Yeah.
snow is like this thing that slows down the water. It's a very slow water, so it's
And
keeping.
also just cooling the surface temperature. Like we know,
Yes,
I'm sure you've
right,
played around with those infrared thermometers, that like a covered soil might be like 80 degrees, and an uncovered soil might be 160 degrees,
right.
just the surface temperature. And then that impacts the air temperature. So then you might have 20, 30 degrees warmer air temperature right above pavement versus versus soil versus grass, like it could have a huge difference in the air temperature. There's a really interesting article in The Guardian recently about botanical gardens being between the air, in them is like between 10 and 18 degrees cooler than the street right next door.
Right.
So as the air temperature is less warm, because of the way we're managing the surface, then there's less evaporative pull from the soil,
All
and
right.
it also could potentially help even with the snowpack issue, so that we have a longer seasonal stream flow from those tops of the mountains.
Yeah, cooling is super key, and yeah, that's the benefit of hydration. And then there is a danger because right now a lot of people response is like, oh, we need to chop down this redwood tree, need to chop down this because of the fire to prevent it. So what that's really important to get out the information of hydration, because if you can really hydrate that vegetation, you actually don't need to chop it down for the fire prevention.
Or
So
if we
it's
can
kind of
recognize that it's hydrating itself through that,
yeah. So
farmers.
actually, what we really want to do is look at hydrating. So it's actually protect because it's hydrated, like the Nick Steiner experiment with the the flammable thing when he shot it
Yeah,
at the
yeah.
hydrated plant, it didn't burn. That's kind of key knowledge that people need to take on. Yeah. So anyway, yeah. So there's this whole. So I think we kind of came up with a good
Yeah,
smorgasbord of a
okay.
lot of things from the local to the the local government to the state level that kind of can be done. Yeah.
So it's interesting that we just did that because there was this global earth repair conference planned in Port Townsend, convergence planned in Port Townsend in May, that has been postponed, but I am going to be hosting a smaller version of it here in Vermont on those almost the same dates, the 10th through the 14th. And
Mm-hmm.
our aim is to take specific locations and to do just what we did, to have a rich conversation with several people and people from different backgrounds and disciplines, uh, and and to come up with, okay, here's the plan. Here's the plan for the neighborhood or for the city or for the state or for the whole region, the bioregion. Here are the things that if we intervene here, here, and here, all these other things are likely to change. So we
Mm-hmm.
want to start coming up with this global earth repair action plan, but that is bioregionally focused. Like we don't, originally it was like, oh, we'll talk about soils in this group and water in that group. And I was like, you can't talk about those separately. That's how we got to this problem. So I suggested that we take context specific situations and
Mm-hmm.
unpack them and really start to see how does it all work together in the Central Valley or in, LA or in, Boston or wherever. So depending on who comes, we'll pick a few regions or bioregions to think about and hopefully come out with some write-ups of that we can hand over policymakers, people in the neighborhood, et cetera, to say, here, this is how you're going to prevent flood, fire, drought, social unrest, water insecurity, food insecurity, landslides, you know.
Yeah, I think a bioregional plan is super key actually, and you can actually hand it to the local hydrology department or whatever, and it's really impactful. The transition town movement was actually started when the permaculture students came up with a plan for, I think, Kinsale in the UK, and like how do you deal with the economics and the
Yeah,
revegetate, and that became a viral movement. And I do think that permaculture students actually do permaculture designs for their course. Their final project is to do a design plan, often for a piece of land, but what we could do is have the permaculture students also get the whole pie region, like whether it's like LA County or Cascadia or
yeah,
wherever, and you work and they work on a plan, watershed plan or soil plan for the whole region, and soil water combined land plan. But they could also, and then the permaculture, because it tends to be an insular community, they could over time actually begin bringing the city planners and city
yeah.
university students who are studying city planning and work with them, and let's come up and local hydrologists and come up with this plan, watershed soil land plan, for how actually you restore the water cycles, and deal with fires and also other things, droughts and floods.
Yeah. Yeah. So that's my thought is you bring in some permaculture people, you bring some people doing holistic management, you bring some planners, regional or city planners. You bring some, maybe a few policymakers who want to jump into the conversation, or maybe that's later. But and then some people who are there as like, you might have a few kind of reference librarians who can go like quickly look up some stuff, and
Mm.
some folks who are good at modeling, some folks, so
Yeah, the
uh,
academics are kind of
different
key.
disciplines who
Yeah.
who can kind of piece it all together, but that you're really starting it from a holistic perspective of like how
Right.
does it all work together.
Yeah.
So that we're multi-solving, we're not 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 spending a lot of time and energy and money in doing something that is just treating the symptoms.
Cool. Well, I think that was a really good overview of everything.
Yeah, that was a fun conversation.
Cool. Well, thank you so much.
All right, thank you. Yeah, thanks
It
for
was a
the
very
invite.
inspiring conversation.
Yeah.